Hey guys, welcome to another tutorial. Today we'll be looking at continuity. And we know that when we're looking at limits, we can look at limits in a sense of are they continuous or discontinuous? And we can also look at types of discontinuity. So for a limit to be continuous, it must satisfy three criteria. First criteria is that the limit as x approaches a of f of x, it must exist. What does that mean? It means that the limit as x approaches a from the left hand side of f of x must equal the limit as x approaches a from the right of f of x. The second criteria is f of a must be defined. And the third criteria is that the limit as x approaches a of f of x must equal f of a. Now, this last criteria just means that our first step and our second step must be equal. So while looking at continuity, we can also look at open interval and closed interval continuity. And that's typically denoted by these brackets here. So open interval has regular brackets and closed interval has square brackets. Now the definition of an open interval is a function is continuous at the open interval AB if it's continuous at every point along AB, while the closed interval, its definition is the same as the open interval, but it includes the endpoints A and B. So if we had let's say a group of numbers 1, 2, 3, 4, 5, and we say it's continuous at the open interval 1 and 5, that means that it's continuous at 2, 3, and 4. So at these points, 2, 3, and 4, it would be continuous. The function would be continuous. Now, if we say we have a closed interval at 1 and 5, it then becomes continuous at 1, 2, 3, 4, and 5. So let's say we're given the function f of x, and we're given some conditions as it relates to f of x. So we're given subfunctions as cx squared plus 2x, and that's only applicable if x is less than 2. And let's say our second function is x cubed minus cx. Our condition is when x is greater than or equal to 2. So a lot of the times when you have continuity questions, they're going to be presented in this format. We're given a function and you're asked to find if it's continuous. So let's say a question asks for what values of the constant c is the function continuous on the open interval infinity to negative infinity. So to solve this question, we can look at our rules for continuity. And we can write that the limit as x approaches a of f of x must be equal to the limit as x approaches a, forgot my signs, of the right of f of x. Now, how would we integrate what we have in our function into this equation? So we can look at our function and we can say that on a number line, so if we draw a number line on the screen here, our numbers in our conditions, so our conditions are these values on the right, so that would be our conditions. Our number on the right hand side, our conditions are the same. So we can assume that the middle of our number line is 2. And then attached to the condition is our x value. So we can look and we can say when x is less than 2, meaning approaching from the left hand side, our function is cx squared plus 2x. And when x is greater than or equal to 2, meaning approaching from the right hand side, our function is x cubed minus cx. So now that we established what our two functions are in relation to the left and right hand side, we can write the limit as x approaches 2 from the left hand side of cx squared plus 2x is equal to the limit as x approaches 2 from the right hand side of x cubed minus cx. Now we can do some direct substitution. So we'll put 2 into our functions and we get c times 2 squared plus 2 times 2 is equal to 2 cubed minus c times 2. We can see where c times 2 squared is 4c, 2 times 2 is 4, and then that's equal to 2 cubed is 8, and then 2 times minus c is minus 2c. Let's get our c values on one side and our other values on the other side. So we can write 4c minus, actually that would be plus 2c, because we're bringing a negative 2c over the equal sign. And then this becomes 8 minus 4. Now we have 6c equals 4. C would divide 4 by 6. So 4 over 6 is our answer, but it can be simplified to 2 over 3, because 2 into 4 is 2, and 2 into 6 is 3. So this 2 over 3 is our value for c, of which our function f of x would be continuous. Now let's look at another question. So for our second question, we're given the function. For our second question, we're given the function h of x, and that's equal to x squared plus 2x minus 3 over x plus 3. And we're told to identify the discontinuous points in this function. If we wrote this as a limit, so limit as x approaches 0 of x squared plus 2x minus 3 over x plus 3. So let's not write 0 here, because we're going to assume a value. So we can assume that if x is negative 3, so if this x right here becomes negative 3, our denominator essentially becomes negative 3 plus 3 equals 0. And when our denominator equals 0, our function is not continuous. It doesn't exist. Remember, our first law, our first condition of continuity is that the limit as x approaches a of f of x must exist. So we can assume that at negative 3, there might be a point of discontinuity. So now that we have our assumption at negative 3, it will be discontinuous. Let's work this function. So let's simplify it first. This would be equal to, we're looking at our numerator here, we can see that we can factorize. So we can have x plus 3 x minus 1 over x plus 3. Okay, we see that we have values that we can cancel. So we can cancel our x plus 3 in our numerator and denominator. That would leave us with x minus 1. So looking at our function h of x, we know that h of x is not continuous at minus 3 at the base function up top. So up here, it's not continuous at minus 3. So we can say, since h of x is equivalent to x minus 1, when x is not equal to minus 3, right? But h of x is undefined at x equals minus 3, sorry. X equals minus 3. Well, we can say that there is a discontinuity at x equals minus 3. Moving away from our question, we can look at discontinuity. There are different types of discontinuity based on our function. We have our jump discontinuity, and if you're supposed to graph jump discontinuity, let's say this is our graph, and we have a function coming in here, and we have another function over here. We can say that, and this is a. We can see that there's a gap between our point coming in from the left hand side and our point coming in from the right hand side. Meaning you could not travel across our yellow line from the right all the way to the left, nor could you travel across our yellow line from the left all across to the right without having to pass over breakage. So that would be our jump discontinuity. Have our infinite discontinuity. So let's draw another graph here. So our infinite discontinuity would look something like this, where we have values going up and then we have values coming down. But at A, there's never a point where our left hand side and our right hand side actually come in line with A. Another type of discontinuity would be removable discontinuity. If we're looking at our graph here, we can say that a removable discontinuity, so let's say this is our function, and this is point A. That's our function, and at point A, you can see that coming up from the right hand side, we can traverse that yellow line all the way to the left, and coming from the left hand side, we can traverse the yellow line all the way to the right without going over any breaks. And you would say this is a continuous function, but there is a value A that exists that would make it discontinuous. So there's a value A that would change how this function is drawn on a graph to make it not continuous or discontinuous. So let's look back at our question and we can try and figure what type of discontinuity this is. So h of x would be continuous at -3 if we left our function as is. So how we got the function, if we just had it as is, when x is equal to -3, our function is discontinuous. But if we simplify our function, or we find our equivalent function of h of x, we can see that if we still use -3 in this function, it would equal to -3 minus 1 equals to -4. Therefore, depending on the values you insert, it becomes continuous or discontinuous. So then we can write that h of x when x is equal to -3 is a removable point of this continuity. And that would answer a question.